We said yesterday, whenever you have an equal sign, you're solving. Whenever you have an expression, you have to keep your fraction. But an equal sign, get rid of it. Find your common denominator. Your common denominator between 2 and 4 is 4. This is one term, this. It's just like as if I said this, 2a plus 4a. Those are two terms. If I'm going to multiply this guy by a 2, I just multiply this one times this, right? I just multiply one of those factors. I don't multiply both. So if I multiply this guy by a 4, and this guy by a 4, and this one by a 4, all I multiply is my fraction. 2 goes into 4 2 times. 2 times 3, 6. Okay. 4 goes into 4 once. 1 times 1, 1. And there's a little 1 here, just so that you remember to distribute it. And 4 times 0, 0. So there you are. You have no fraction left. You just have a regular equation. Be careful of your subtract sign. You have to distribute that subtract. Whether you distribute to -1, whether you say take the opposite and add, whichever way you're more comfortable with, but that has to get distributed and solve. Now, you had no restrictions in this domain because you had a fraction but no variable in your denominator. So there was no domain restriction on this. And you just, whatever answer you get, you're good. Stop me if you have questions. Get past that phobia of fractions. I find every class I have, it's as soon as I hit a fractional equation, they stop. But it's the same process. God bless you. You could take any equation you want and multiply every term by something. It doesn't matter. If I give you this, you could multiply every term by 3. You're going to get the same answer. You can divide every term by 2. You're going to get the same answer. So as long as you do this to every term, you're fine. You kept the balance there. And that's what we use with fractions. We take the denominator, we multiply every term by it, and we get rid of that fraction. Stop me if you have any questions, because this is really important. Make everybody have a fraction. Put this over 1. Between 3 and 4, what number would they both fit into? 12. Say that to yourself. The top of every one, 12. I'm not multiplying the numerators. I'm dividing this out first before I multiply. I multiply this by 12. Don't forget to multiply every term by 12. 3 goes into 12 4 times. There it is. 4. 4 goes into 12 3 times. And 6 times 12, 72. Then you have a nice equation. No restrictions, because even though we have a denominator, we have no variable in the denominator. Good? This next guy, you had a choice. You could cross multiply this. If you cross multiply, make sure you have parentheses here. And in this case, they cross multiply. If you find a common denominator, you can do it that way too. You can multiply 3 times 5x plus 4. 3 times 5x plus 4. Out comes the 5x plus 4. 3 times 5x minus 4. Out comes the 3. 2 times 5x plus 4. You get the same exact process. Whether you find a common denominator or you cross multiply. You can only cross multiply when you're one term. Otherwise you can't. And if you're going to have to get a common denominator for one side, you might as well just get rid of the whole common denominator. This is the same thing when you do a complex fraction. And I'm sure you guys panic over complex fractions. If I give you something like this. Oh yeah, same process though. Find me a common denominator. 4x. So, 4x. 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 You get rid of them. 4 times 2, 8. 4 comes out, plus x. 2 goes into here, 2x. You just got rid of your complex fraction. Same process.
They're never that easy.
Well, yeah, but that's the same process no matter what you do, though. No matter how bad they look, Get rid of the denominators, all at the same time. Don't just do the top and then flip the bottom. It's too much work. Get rid of all of them at the same time. Okay? All right. This was very similar to the one we did yesterday. We did the x plus 2, x minus 2, x squared minus 4. Same process. So this went into the same factors. These are your perfect squares. So your common denominator is x minus 2, x minus 3, x plus 2 on the top of every term. And then you can cancel them out. It just cancels right out. This is just like the example we did yesterday. So out comes x minus 3. 1 times x plus 3. Out comes x plus 3. 1 times x minus 3. Out comes these guys. 10. There's your equation. Okay? Okay, this one had a variable in the denominator. So we set the denominators equal to 0. X plus 3 equals 0. X minus 3 equals 0. So we know we can't use plus or minus 3. So when your answer comes out, if that is part of your domain restriction, it's not going to work. In this case, a 5 is perfectly fine. Then you can check it like you would any other equation to make sure the computation part that you did worked. Questions? Those of you that said you couldn't do it, is it coming back? Easier now that you tried it? Okay. This one was just like the one we did yesterday. Here's another one. Common denominator. I need this group. I need this group. Just say it that simple to yourself. I need this thing. I need this thing. There's my common denominator. Over every term, you put this. And the last guy. Don't forget the last one. And out it comes. Out comes the 2x plus 1. There it is. 7 times 2x minus 1. Out comes the 2x minus 1. 8x, and be careful of this negative also because that has to get distributed, times that. Now this one comes right, it has to be multiplied by everything. If you do this, this is your perfect squares. That might be easier to multiply by 4. Those are your perfect squares. Multiply your first terms, multiply your last terms. Because your middle terms are canceling out. Or you can multiply the first one and then multiply the second one, probably just a little bit longer. And we had a domain restriction. We set both of those denominators equal to 0, so we can't use a half and we can't use negative 1/2. Everything else we can use. And yet that would be a heck of a messy answer to try to test, to check putting it back in. But you can absolutely still do it. You're allowed to have a fraction within a fraction. You can do that. Okay. Get past your fear of fractions. Again, it's as simple as saying, I need an x, I need an x minus 5. I need an x, I need an x minus 5. Okay, and then cancel out your like ones and your left. The right side is nice. Anything times 0 is what? 0. The right side was nice. And they make a nice little equation. That's a lot more doable to handle. Again, we had 2 restrictions. It cannot be, x cannot be 0 and x cannot be 5. It's nice to figure your domain restriction first, because when you get your answer, that's the one you check off of. Am I allowed to use this? If I'm not allowed to use this, I get rid of it. Good? this is missing a 2x. That's missing a 2x, right? Oh no, that's a plain old x. Oh no, that's a plain old 2. Something happened here. Don't just ignore this. Go straight to this one, because that's how we do it. We take this is out of there above, but we go straight to this one. Cancel out your like factors, go straight to this one. Good. Make sure you check. At least check against your restrictions. Again, find your common denominator. Go to each spot. I need an x. I need an x minus 3. Put it on the top of every term. Cancel out. I have 2 restrictions. X cannot be 0 and x cannot be 3. Those will make my denominators be 0. And when we come down to your solution, x is 3. And we say, oh, 3, I can't use 3. Therefore, this is called your extraneous root. We reject it, and because it's the only one that we found, we have no solution. We have to say the no solution, just like you did in Algebra 2. Questions? No? We are fearless in precalc. We have no fear of fractions in precalc. Okay. We have 2 lines that cross. 2 lines can cross once or none. They can be parallel. So because you have y equal, set the y's equal to each other. That's a substitution. And solve. So remember, as soon as you find your x, bring it back and find your y. It's a coordinate pair. And that's very nice to check on your calculator. Put it in your y equal, and do an intersect. And see if it's the same point. Can everybody do, you can do those in your calculator? You do the y equals, and can everybody do an intersect? Or no? Okay. Right. This guy, be careful of this one. You have a parabola. I moved it over. Set it to the y equals. Make your life easy. Can you do a substitution? Can you solve for y and substitute it in? Absolutely. Just be careful of your negative sign. If you solve for x, you can do that too, but then you're going to have to square it in the second one. That's doable too. Set them equal to y. I have a parabola and I have a line. It can cross once, twice, or none. So we've set them equal to each other. Descending x's, you got a quadratic, bring it to one side and factor it. And once you find your x's, find your corresponding y's. Good? No? Okay. Hey, Mark. Any other questions? No? It's just good substitution. And again, 2 lines can cross once or not at all. They can be parallel. So set them equal to each other. Add 2x. Add 3. And x is equal to 4. And then go back and find your y. Make sure you find your y. Right, and I think this is the last one. The graph came separate. I don't know if you noticed it. I don't know why the graph came on another page. But that was the graph to this one. And I think you just had to find the intersect points. It intersected 3 times. There was the W, like the W we did in one of your graphs, when it's raised to the 4th power, and a regular parabola. Okay? Questions on any of these? No? Don't let the fraction. And when we solve a radical equation, you're going to look for any domain restrictions, whether there's one radical, two radicals, three radicals. Most we probably have here is 2. I don't really would ever do a 3. You're going to look for your domain restrictions. You're going to isolate the radical to each side of the equation. If you have one radical, isolate that one by itself. If you have 2 radicals, they both need to be on opposite sides of the equal sign. You don't want to square 2 radicals because you're going to get a middle term of a really horrific looking radical. So keep them to both sides. Then you're going to square both sides to eliminate the radical. It will eliminate it on one side only. And then you're going to have to repeat that process. Isolate it, square it again. This is your worst case scenario, 2 radicals. Okay? You can even graph this if you like. You can graph this in your y1, you can graph this in your y2, and you can see where they intersect. And we say check all solutions because if you have a domain restriction, then there's a problem. So let's take a look at your domain restrictions. Underneath your radical cannot be negative, so we set it greater than or equal to 0 for both of these. That's one thing that we can't have happen. So we solve. We subtract the 6, divide by 2. So somewhere over here, we're greater than or equal to -3 so far. It has to be greater than or equal to -3. We do the same for this one. This has to be greater than or equal to -4. Now, if we go with the -4, this one's going to fail. They both overlap in here. So our domain has to be from -3 to infinity. Because if we use the -4, one radical doesn't work. Right? So you have to use where they intersect, where they overlap. So that's going to be our domain for this. Now, our next step is to isolate your radical. They're both on the same side. Move one to the other side. So that we get rid of the negative at the same time, just add this to both sides. This is the same as algebra 2. Okay. Worst case scenario. Worst case scenario, you have 2. Well, what happens when you square this? And you multiply it by itself? You have this one, which will get rid of the radical. You have this one, which will be a very messy looking radical. This one, same messy looking radical. And this one will get rid of itself. So you really can't do that. It's because it's 2 terms, you can't square this one and square this one. You have to FOIL the whole thing out. So that's why we try to avoid that one. But this one, we still have a similar problem, but we get rid of it a lot easier. So now we can square both sides. This one, when you square a radical, whatever's underneath it comes right out. This one, we have to FOIL. But this is not so bad, because there's only one radical here. You can't square both terms, because this is a binomial. This is like x minus 2 squared. You can't do x squared minus 4. You have to do x minus 2 times x minus 2. Only when you have one term can you raise your path to the power rule. So we'll work this out, where 1 times 1 is 1, or 1 radical x plus 4. Inner terms work plus 1 radical x plus 4. And when we multiply the last term, 2 radicals that are the same, it just pops right out. Now, collect your like terms. We've got a 1 plus 4, we have a 5, plus x, plus 2 of these guys. Okay. 1 plus 4. Okay. So we've got a 5 plus x plus 2 of these guys. Now, same thing. Isolate the radical. Let's move everything else off to the other side. Subtract 5, subtract x. If you could, we could divide by 2. If you could. If you can't, don't worry about it. We'll get around it. But ideally, it would be nice if you didn't have to square that guy. But we don't want to have a fraction and square that. Now, when you square both terms, again, this is a binomial. It's a little bit longer. This says square 2. I'm sorry, I'm going to bring it up here. Square 2, which is 4. 4 times x plus 4. And x plus 1 squared is x squared plus 2x plus 1. Now you got something that's more doable. Worst case scenario, 2 radicals. 2 radicals take a little bit longer. So distribute. And because we have descending variables, get everybody to one side. Subtract the 4x and subtract the 16. And now we can factor. I subtracted 16. I subtracted 4x. I didn't want to write it because I don't have a lot of room here. Neither do you probably. Okay. So x is equal to -3 and x is equal to 5. Now, -3 is within our domain and so is 5. However, radicals usually have a problem, especially if one of them had a negative sign and we squared it. So you have to check all solutions. Because usually when you manipulate your radicals a little bit, something happens to it. Same with an absolute value, especially when there's a negative sign. So check both the 5 and the -3 in your original solution. And if we check the 5, and you can just do this real fast. 5 times 2 is 10, plus 6 is 16, square root of 16 is 4, minus 5 plus, is it 5? 5 plus 4 is 9, square root of 9 is 3. Yep, that one works. Now, check the -3 for me while I grab this one. Sure will. Okay. Isaac, if you could stop by guidance at the end of the period. Now, test your -3. -3 times 2 is -6. This gives me 0. -3 gives me a 1. Be careful. Does that work? 0 minus 1 is 1? No. 0 minus 1 is -1. So we have to reject this guy. So your solution is x is equal to 5. That's the one that works. This is worst case scenario. Worst case. I figured let me do the toughest one with you. The process is always the same. Isolate the radical, square both sides. That's the worst. That's the worst one you're going to see. Normally you just see like something nice like this. So you isolate your radical. You add 4. I mean, this is like simplest, but this follows the same principle. Isolate your radical. And then you square both sides. So x is equal to 169. So you square both sides. But the process is the same, whether we did the simple one or whether we did the tough one. You just have to repeat your process. And you have to remember, whenever you have a binomial, you have to FOIL it out. You cannot square both terms. That only raised to the power works with one term. That's another pitfall kids fall into. Questions? No? Okay, remember to find your domain restrictions first. Alright, so we have a couple of minutes. You can get started on your homework. Some of them you might have to factor. Maybe we'll do number one. Let's do number one together. That's not a radical. That one has to be factored. Some of these have a little bit of factoring in it. Okay. What's the greatest common factor for all three terms? 5x. Take that out. What's left in my first term?
X squared
Plus 6x plus 9. Anything else we could possibly factor? This guy, he's a trinomial. If we bring down the 5x, it's going to factor into what? Good. X plus 3 squared. Good. You went right to the square. Good. Whether you do that or you do x plus 3 squared, either one is fine. Set them equal to 0. And this one you only have to set one equal to 0. They're both the same. And if you did this, 5x equals 0. If you took the square root of 0, what do you get? 0. So there you go. Okay? This had no domain restrictions. There's no fraction, no radical. Some of these might be a little bit of factoring, just to mix it up for you, and the rest radical.